Hello everyone, and welcome back to my series of videos where I'm solving each one of LeetCode's problems, starting with the easy ones when going up to the hard ones, and we're still on the easy ones as you can see. Next one is linked list cycle. So what is this? Given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in the linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. Okay, so pause is like a memory address. Return true if there's a cycle, otherwise return false. So I guess we can assume that all of these values are unique. If these values are unique, we can just save the values that we visit, and if we visit them again, we can see, oh, yeah, if we saw this value again, then there must be a cycle. So if that is the case, so we just create a set visited, and that is a set, and so while true, it's going to loop forever. If, okay, while head, if if head dot val in visited, return true. Yes, there is a cycle. If not, we just do visited.add and head.val, and then we go and we say head equals head.next. And then we return false if it goes all the way to the end. See if it works. Yeah, it works. Okay, why didn't it work? Position is -1. What does that mean? Expected false. Why is it false? I don't want to copy all of this to my VS Code. Ah, expected false. The only reason why this happened is set saving values on their absolute value and not their negative value. Because we have, wait, we have 21 and -21. -21 and -21. Output true. Yes, we have a cycle. Expected false. But there's a set. Oh, wait. I maybe it's only a cycle if the if headValent visited and it's the last one and head.next is none. Yeah, but head.next can't be none. It needs to return to it. So how do I know? I'm not sure if I'm understanding this exercise. Yeah, it's running forever. Time limit exceeded. Okay, test case. Oh, and it's -1. What does this mean? There's a cycle in linked list, and there's some node in the list that can be reached again continuously following the next pointer. Internally, pause is used to denote the index of the pointer. That tail is the next pointer is connected to. No, pause is not passed as a parameter. Goes back to it, it goes back to it. So if pause is -1, then there is not a cycle. But how should I know that there is a cycle? So where does this 5? How do I reach this 5? Okay. Okay, I get it. Okay, so if I reach this one, so if I so I found -21, and then I find -21 again. Cool. I need to see if the ones that come after -21 are the same that come after -21 over here. That's where it gets hard. So what I can do is can do it differently. I'll have something like so I can count something like, yeah, I found -21 again. If I find -21 the third time, let's check if the number of elements that we traversed is the same as we traversed when we found it the first time. Yeah, but that doesn't make sense because we could have -21 in the middle and it wouldn't be a cycle. So let's just do it another way. So we know that the values are not unique. But if the values were unique, that would be helpful. So what I can do is so let's just do original head equals head, and we're going to keep it. And while head, and then we can do this. Visited equals set. While head, same thing. If head then visited, then we're going to do something which is not return true. Visited at add.val, head equals add.next. I'm just going to do something different. Add dot val equals UUID, or from, let's see, how does it go? From UUID import UUID 4. I think I can just run it UUID 4 X. Yeah. I need a better mouse. Okay, UUID ID 4. Press save. Okay, so if uh if head val visited and head of val, the type is string, so if not, we can head equals original head and continue. But it's running forever. So my objective here is, well, I don't know if the values are going to be unique, so I'm going to make them unique. I'm going to create unique values for each one of them. And if I find the same unique value that I know it's unique twice, then yeah, I know for sure that it is a cycle. But the problem here is if add val visited, I still need to do this. I still need to have this value here. Otherwise, it's going to loop. And I can remove that value. Can I remove that value? Maybe. No, I can't remove that value. Okay, let's just run this locally. A directory, and this is problem 141. List cycle code 141. Solution.py. And now linked list is going to be equal to this. I need to copy this class. Okay. This is enough to start. And I can say A is equal to linked list list node of I can't even define this locally because I can't even pass the next. This is very weird to work with. Oh, I guess I'll have to do this. Maybe they made a mistake with the commented code. So yeah, list node is 1 and nothing. B is list node of 2 and A. C is list node of 3 and B. And D is equal to list node of 2 and C. So I guess that this doesn't have a cycle because it goes all the way to 1, but it does have 2 values in common. So now I need to do has cycle solution has cycle of D. And let's see what happens. Okay, original head, visited, anti-set, well head. So head is this that has, and next that has nothing, that ends with ones. 2, 3, 2, 1. Okay, cool. If head val visited, well, it's not visited dot add 2. So visited just has 2. Head next. This is a free, I guess. Free. Okay, so now it's a 2. And it is invisited. So if it is a string, it's not a string, but the val is going to be the UUID, and it's going, and I just replace head with the original head, which has a UUID. So we just continue. If head val visited, well, it's not. While head, it's not. Yeah, it doesn't have a cycle. So what happens if it does have a cycle? I guess that I can write this. So D connects to C, C connects to B, and B connects to C again. So I can do B dot next equals C. So let's see if this works. B next next, 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 next. Okay, it's going forever with the next. So okay, so we have a cycle. Let's just skip all the way here. Okay, so add val is 2. So now head has something like this. I'm being very stupid. Okay, so if type of head.val is integer, then we replace it with the UID, and then we do the rest. Otherwise, doesn't make sense to do this. Run. UID is not defined, of course not. So I was always recreating new UUID values, but I don't want to do it. I only want to do it if the values are integers. Okay, and it still didn't work. Let's see why. Okay, so add original head continue. Add visited added val. It's not head equals head up next. Add val. No, head up next. Add val. So head.val is visited. If string, if type of head.val is string. Yeah. So type. Submit. Okay, wrong answer. Why? The output true. How is this? How is this true? So copy this. I'm gonna recreate this. For I in this. List node. I think I should do it the opposite way. So I'm going to reverse this. This one. So I'm going to create. So A is none. And I'm going to create A equals length list node of I, and then the next will be A, and I'm just going to do it all the way to the end. I'm running this. Okay, so A is, it should be Minus 21, 10, 17, 8, 4. Minus 21, 10, 17, 8, 4. Yeah, okay, cool. So let's see. Return false or return true. What's this and isn't it? Oh, I get it, because we're going all the way over again because we found. Okay, I think that once we find the once we find an integer that is repeated, we need to remove all the integers from the visited set. I think I can even reset the set. I shouldn't have removed the cycle thing. Yeah, okay, if it's string. Let's see if this works. So basically what I'm doing is, whenever we find uh, an integer that we saw before, we reset everything. And we only really break if we find uh, the same what, if we find the same UID. Run this, see if it works. Works, submit. Okay, this is not an efficient solution, but it does work. What we could do is probably have like save points. So something like, yeah, we went here all the way to here. So we have the same value. So we don't need to start everything from scratch. We can start from here and then go on. Let's see what people wrote in their solutions. Two pointer, void cycle finding algorithm, fast slow approach, shorted and hard. Move one pointer by one and another pointer by two. If these points meet at the same node, then there's a loop. If the pointers do not meet, then linked list does not have a loop. That's actually a good point. Yeah. I wonder if this can hop over the other one. So let's see. If two, I'm on two, so it start on the one and then two. Two goes to four, and one goes to two. Two goes to three, four goes to two. Three goes to four, two goes to four. Oh, this is actually super smart. I'm going to implement this. Forget all about this. So head slow equals head, and head fast equals head.next. Yeah, but how do I know that they're the same? They might have the same value, but how do I know they're exactly the same? It's equal. Oh yeah, we're comparing objects, so we're comparing memory values. Yeah, so uh, while true. So if head slow equals head fast, return true. So while head slow is not none and head fast is not none. If they're the same, so I'll just say that head slow equals head slow dot next. Head fast equals head fast dot next. Might be none. And if not head fast, or if head fast, same thing again. Because I don't want like to have an exception because I'm doing like none dot next. So return false. See if this works. Well, I guess it does. So let's try it again. Run. Submit. Head fast. Head dot next. Yeah. I think this is on line 53. Line 53. Maybe it's, oh, no, yeah, it's this one. So if not head, return false. I feel like I learned something today. Okay, so it's doing a lot better and just a little better in memory, but a lot better in time, which is the important thing. Beats 99.29. Well, I wasn't original, but at least I learned something today. Hope you guys did too. Have a great day.